The general formula for a vertex is given by x squared over a squared plus y squared over b squared equals 1, where the a is the length of what we call the major axis, meaning that it's the longer axis. So the whole major axis would have distance to a because it goes from negative a to positive a. And then the length of the minor axis is considered to be 2b. So if this is centered at the origin, then this point would be 0b as an example. Now, where the actual definition for an ellipse comes from is if we take a general point on the figure, okay, so call it xy, then it's defined to be all xy that have the following in common. If I say that there are 2 points that we call the foci, remember we had a foci or a focus in the parabola, and we actually have 2 foci in the ellipse, and these are 2 points so that if you define a set of points xy so that the distance between the first focus and xy and the distance between the second focus and xy, so you add those 2 lengths together, and it's going to be the same for all points. In other words, if I choose another point over here, and then I take this distance plus this distance, is going to be the same as d1 plus d2. So that's how we're going to define it, that the sum of those 2 lengths is equidistant. And I think you'll see that if we just start with that definition, we'll be able to derive where the particular formula comes from. And so I'm going to claim to start that d1 plus d2 is equal to 2 times a. And I think if you recognize that if the point negative a, 0, for example, is on my ellipse, then if I take the distance from that point to the first focus, and then I take that same distance or the same point to the second focus and add those 2 together, since this value right here, or this distance right here, is the same as this length right here, then the 2 green lengths in question are going to add together to give me the same as the length from negative a to positive a, so that's where the 2a comes from. And since that those 2 distances added together have to be the same for every point on the ellipse, we can claim that d1 plus d2 is equal to 2a for all xy. Okay, so let's just follow that. So d1, and I'm going to go back, I'm going to define my d1 to be the distance between negative c0 and xy. All right, so that distance is given by x minus negative c squared plus y minus 0 squared. All right, and then my d2, now I'm going to look at this distance right here. All right, so that's going to be x minus c squared plus y minus 0 squared. And so add those 2 together and we get 2a. Now, it's a kind of a tedious calculation, so I'm just going to write this out. What we have is the square root of x plus c squared plus y squared plus the square root of x minus c squared plus y squared is equal to 2a. And we've done this before where we want to simplify an equation that involves radicals. And remember, it is kind of messy, but the idea is we keep one radical on one side and move the others to the other side. All right, so if we have the square root, I'm just going to multiply this out, of x plus c squared plus y squared is equal to 2a minus the square root of x minus c squared plus y squared. Now when I multiply, or when I square both sides, I get x plus c squared plus y squared is equal to, remember we treat these two terms as a binomial, so when we square the binomial, we get 4a squared minus 2 times 2a times that radical expression plus x minus c squared plus y squared. So that's this second radical squared. Okay, and so now we're just going to simplify a little bit. I'm going to square that binomial. Still have this binomial intact. I'm sorry, radical intact. And then x minus c squared would be x squared minus 2xc plus c squared plus y squared. And now we can see that some of these guys are going to cancel. My x squareds are going to cancel. We have a c square and a y square that cancel on each side. And then I can bring this over to the right so that 2xc plus 2xc, let me go back to my pen. All right, 4x squared, I'm sorry, not 4x squared, 4xc, 4xc is equal to 4a squared minus 4a times the square root of x minus c squared plus y squared. You know what, let me change that just a little bit. I want to bring the 4a squared to the other side of the equal sign. So let me just change this. And then what we have is 4xc minus 4a squared equals negative 4a squared times the square root. And I can divide through by 4 and get xc minus a squared is equal to minus a times the square root. Okay. Now, if I go ahead and square both sides, because now we want to get rid of this radical expression over here. If I square both sides, I end up with x squared c squared minus 2 times x times c times a squared plus a to the 4th. And then on the right, we get a squared times everything in the middle. All right, now I'm going to go ahead and multiply x minus c squared. I would have x squared minus 2xc plus c squared, and then plus y squared. Okay. All right, so now I can see that if I expand my a squared out here, so multiply through, I have a squared x squared minus 2xc a squared plus c squared a squared plus a squared y squared plus over there. All right, so my x squared c squared, oh, I don't have an x squared c squared. Never mind, that doesn't cancel out. Let's see. What we want to do now is I'm going to put my x and y terms on one side, and then I'm going to put everything that doesn't have the x and the y on the other side. So now I'm going to get, let's see, we're going to move this to the right, and we're going to move this to the right, and we're going to move this over to the left. Oh no, we're going to keep that on the right, and we're going to move this over to the left, and we'll move this one to the left. So basically put your x and your y squares on the right and keep your a's and c's on the left. And what we end up with is x squared, c squared, no wait, let's see, that is, that's going to go on the right. Okay, but what goes on the left is our x squared. Oh, shoot, I did it again. I keep seeing that and writing it. But what goes over here is our a to the fourth. And then we have a c squared, a squared. And then, let's see, these two guys are going to cancel. And then on the right, we end up with x squared times a squared minus c squared. All right, so that was this one. We bring it over to the right, and this one. And then we have plus a squared times our y squared. All right, sometimes some of my c's and a's look the same, so sorry about that. You just kind of have to go back and clarify. Okay, so I can write this left term as, I'm going to factor out an a squared, and the reason I'm going to do that is we've got a squared minus c squared over here, and then if you'll notice we have a squared minus c squared over here, and then we have a squared times y squared. Now I'm going to claim, and I'll go back and do it in just a minute, and where we get that claim from, but I'm going to claim that a squared minus c squared is equal to b squared. And so what we have when we make that claim is that a squared times b squared is equal to x squared times b squared plus a squared times y squared. And this is actually what we're going for, because if I divide through by a squared, b squared, what I end up with is 1. And dividing this by a squared, b squared, my b squareds cancel. So we have x squared over a squared. And then if I divide this by a squared, b squared, my a squareds cancel. And I have y squared over b squared, which is what we're looking for. So just by making, the point is, and we did something similar with the parabola, but just by making that definition very common sense, okay, an ellipse is defined to be all points that are the distance between the two foci. When you add them together, you get the same value. If we start with that simple claim, we can write it mathematically, and then we're able to derive where the mathematical equation comes from. And we did something similar with the parabola, and that's a cool analysis technique. I know this was tedious, but I just want you to start seeing where mathematics makes sense. It's not just a bunch of numbers, but it's taking situations that can be defined from a real problem that exists, and then assigning a numerical value to it and assigning a mathematical language to it so that we can manipulate and solve the problem that we have. And that's just what I want you to start thinking about. I know this was long, but I want to show you one more thing. And I know you may be asking, where does the a squared minus c squared equal b squared claim come from? if we take specifically that point B that's on the minor axis, and we know that those two yellow lines together also equal to A, well, let's look at that distance. How do we get that? I guess I'll go ahead and use yellow. But if we recognize that the distance from the first focus is the square root of c squared plus b squared, so that's just using the distance formula. And then same thing, the distance on the second from the point to the second focus is c squared, square root of c squared plus b squared. Add them together and we get 2a. And we just, it's just simplifying that equation. Trying to eliminate the radicals. Eliminate the first one and we get c squared plus b squared equals 4a squared minus 4a times the square root of c squared plus b squared plus c squared plus b squared. Okay, and so those guys are going to cancel. And we end up with 4a times the square root of c squared plus b squared is equal to 4a squared. All right, so divide both sides by 4a, and we get, I think you're seeing where it comes from now. That one was, yeah. And then we square both sides, and we get c squared plus b squared equals a squared, or b squared is equal to a squared minus c squared. And there we have it. We're asked to graph the ellipse 25x squared plus y squared equals 400. Remember, we just learned that ellipse is of the form x squared over a squared plus y squared over b squared is equal to 1. And this obviously isn't in the form, but notice we want a 1 on the right side. So let's divide through by 400, and that will give us the 1 that we are looking for. So simplify, I get x squared over 16 plus y squared over 400 is equal to 1. Now, that means that the vertex or the endpoint associated with the x-axis is going to be 4 and negative 4, because 4 and negative 4 squared is 16. I'm going to let that be our negative 4 and that be our positive 4. So we'll have a scale of 2 on that. And then the value associated with the y squared is 400, which means that we're going to go, since 20 squared is 400, we're going to go 20 on our y-axis to get our endpoint. And let's see, so if each of these are worth 2, then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We've got a vertex here and then a vertex down here. Now traditionally, the minor axis endpoints, in this case the minor axis would be the x-axis and the major axis would be the y-axis, just because, you know, it's bigger. And basically we get something like this. There's my dog barking. She's found a friend outside. Okay, so there we go. The only other difference on the ellipses, this is the only problem I'm going to do for that, but let's say that the vertex was here. You know, you had an ellipse, but you shifted it over. And so, you know, this traveled this distance. Let me change the color so that, you know, the same, or the same shape, but just scooted over, say HK units, so that, you know, it travels whatever, more like that. We'd take the same equation and it would be x minus h squared over 16 plus y minus k squared over 400 is equal to 1, where, this is our vertex HK. So this, the point is the shifts, the horizontal shifts, and all that still apply to our ellipse and the ellipses the same way that they do to our functions that we study. Okay, so back on the blue, there you might be asked a few things like what are, the domain and the range. Now this obviously is not a function, but it's still a relationship, it's still a figure. And so the domain is, still the x values, and the x values go from -4 to 4, so that's our domain, and then our range would be -20 to 20. And then you might be asked the vertices, and the vertices would be in this case, just because it's sitting, centered around the origin, 0, 20, and then 0, -20, and then the major or the minor endpoints would be -4, 0, and +4, 0. The only other thing that might come up, I'm going to erase this just to give us a little more room. Oh, I guess I can't. Oh no, there it goes. Yeah. The only thing that might be asked is to find the focus or the foci. And remember that we learned on the previous slide that our b squared, we have the relationship that b squared is equal to a squared minus c squared, and the c is the focus. In this case, our b squared is associated with the x-axis, so that's going to be 16. And then our major, our a squared, is 400. And so we get c squared is equal to 384. And it's going to be plus or minus, or actually c is just not plus or minus. C is one value, which is, that's 8 square roots of 6. So our foci are going to be 0, 8 square roots of 6, and then 0, -8 square roots of 6, which would be, I don't know, somewhere here and here, just guesstimating.